Good morning. I'm Daryl Brugink, Executive Editor with No-Till Farmer, and I'd like to welcome you to this morning's webinar where we are going to be talking about setting a benchmark that puts farmers on the path to effective plant nutrition. And I'm sure you guys hear a lot about how you need to fine-tune your fertility program, but first and foremost, you really need to make sure you have the basics of fertility in place. Today's No-Till Farmer webinar is sponsored by FHR out of Stewartville, Minnesota, just outside of Rochester. And here to help us learn more about the ABCs of sound fertility programs is Jeff Luttrell, founder and CEO of FHR, and he's also a farmer of about 2,000 acres. We look forward to hearing from Jeff in just a moment, as he's not only going to cover the basics, but he's going to get into some of the tools of fertilizer placement, some soil biology, soil testing, and also timing and placement of nutrients. So before we turn things over to Jeff, there are a couple of items I want to make you aware of. On your screen, there is an orange box with a white arrow inside of it. When you click on that, it will open up to reveal a question or comment field that will allow you to submit questions at any time during the presentation. And at the end of the webinar, we will look to answer as many questions as possible as time allows. So with that said, I want to thank you again for joining us, and I'm going to turn over the controls to Jeff Luttrell. Hey, good morning to you, Jeff. Thanks for presenting today's webinar.
Thank you, Daryl. Thank you, Cole, and all those at No-Till Farmer, and thank you for those that are in the audience today. It's a sunny, wonderful day up here in Minnesota. We can see all kinds of white sand. Oh no, maybe that's actually white snow, and we have a blizzard coming in. So it should be an interesting day for us. So what we're here today is to basically setting a benchmark for effective plant nutrition. Basically what we've done is to go forward. Now can you hear me yet, guys? Okay. At any rate,
we do hear you, Jeff.
Is a soil approach. Okay. A soil system, a group of units so combined as to form a whole to operate as a unison, a group of organisms that together carry on some vital function. Realistically, what we want to cover today is the process that we at FHR Inc., as well as what we do on our farms, and the clients have been with us probably over 20 years. So our goal is to basically start out the whole approach to help you understand that the system is going to come down to soil biology. You hear tons and tons of things out here on a daily basis now, with the null design coming into play and all that they've done, and the ADMs of the world. Biology has been a very, very important key role. Well, comically, we've been doing this for probably 20 plus years, looking at biology, probably dating back into almost into the 80s, so almost 30 years. But some of the critical things that we want to look at is basically the process. Now, there are basic units of the FHR system. Notice that soil biology is in the center, where it should be. The beneficial or detrimental parts of the soil biology is driven all by that. We understand this and have put together efforts moving into soil biology and the proper use of chemicals, tillage or not tillage, laboratory testing to see and make progress, so we can basically give it the full mother load. So as you look at here, you'll see soil biology, soil testing, fertilizer, and application, which are all very, very critical to the system. So we'll start with a soil test. As you look at this test, you're going to see some things on here that are very, as we start out with, unusual for most people. And what we're going to talk about is the first one is the Lamont or Morgan test. Ironically, not a lot of people know of this. You understand the Malik or the Olsen-Bray. There's tons and tons of testing systems, tons of labs out here. We have found in the last 34, 35 years that this test, in conjunction with an Olsen-Bray or a CEC test, are what we consider to be the best parameters to measure things with. Now, remember, a soil test is only a measurement of what is there, ironically, at that given time, in that moment, in our soils. So first, what we're going to look at is a tons of stuff here. This was corn grown in 2013, humus level. Glyphosate reduces biological activity. We can have tons of discussion on that. There's tons of individuals. Brummer out of Missouri, a USDA researcher, will tell you that there is activity issues or destimulation. So some of the things we're going to look at build humus to get that level back up. We'll be looking at grasses, corn on corn, rye, wheat, as cover crops. Numbers to increase holding capacity of nutrients, and water will increase using residues, digesters, micropack, one of our products in Behium. The individual that taught me this, for every 1%, so if we 1% of humus in these soils, we have up to 0.44 inch of water holding capacity. So this is very, very critical. Don't mistake humus for organic matter. This is the difference. This is the brown gelatinous gel that holds that material. It's a measurement that holds that material together. The next thing that we cover would be nitrate and ammonium. The reason we look at both, because they're critical to growth. One's going to control your overall vegetative growth. One's going to control the reproductive growth. The next thing that we go to is looking at this is phosphorus. As we look at that, we measure, except for the humus, what you're going to see right now are all pounds per acre in these systems. So if we look at that as phosphorus, and we like to see it at 1-to-1 on the Morgan or Lamont test ratio. So we want to see at least 1-to-1. We're not worried about higher levels of a K. We feel that as you get a good system and understand the Krebs cycle, all elements except for nitrogen go into that plant in the form of phosphorus. So we have to be very critical of that. So we take a look at potassium. It's a needed element. As you can see on this test, we'll see 18 as a phosphorus as what the plant can see. And that's what this soil test measures on that Lamont. And you look at the soil test on the K levels are at 227. Then we go over a little bit of typo there. The calcium, we like to see it at 3,000. We're at 3,088. We like to see that at a ratio 7-to-1. And there's all kinds of comments on that. But in 30-some years of doing this, we found as we get those ratio closer, we keep that mag down. We can do things such as Keith Schlapp goes down to his farm. One of the partners, he's president of FHR on his farm, where he's using that 100 pounds a N to raise 200-plus bushel corn. In the case of we're not quite there. We don't have some of the tools at our disposal, but we are seeing similar things. So if we get down to the next phase, we look at a pH. Excuse me, we'll back up. Sodium, which we're very good with, you have to have enough A to get there. B, if you don't have enough, you have to add some. So as we look at adding something to that profile, we'll possibly add C solids. Your salt fertilizers in limited amounts can all help work with that. Ergs, which is conductivity, we will measure that. That is a way of actually measuring the level of the soils. 200 is what we consider to be a minimum level, and we like to see higher if possible. Next phase would be pH. We've started a discussion on that. pH can vary. We're very, very firm believers in that. You can see up to 2 points during the year, and we'd recommend that you go out and take a 1 square foot area of soils and actually take that and start measuring your pHs weekly on that process, because I think it's a very critical thing. And you can find out that sometimes, yes, pH is going to make trace unavailable phosphorus. There's many things that go on with that, but it's still a critical issue to look at. It is not the driving what is calcium, what is soluble calcium, and that's misnomer at times. When we look at our trace elements, very, very critical. As you can see there, as this test would be no different than a Midwest test or any other testing system out there. The coppers, iron, zinc, manganese, boron, and sulfur, they're all within a standard parameter coming off a standard testing system, but that is part of that test. We need to know where these trace elements are. We absolutely must know where our traces are, because there's so many issues going on in this day and age with our trace elements. The next one would be your CEC test, the Olsen Bray, which when we go down that, now if you remember back where we're at on the phosphorus, we're at a very, very lower level. And in fact, if I go back to that, we're 18 as what the plant could see. But the Bray one and the Olsen, we're at 46 and 31, which is a very, very good number. So does that mean that we're short according to Lamont? No, it doesn't mean we're short. It just means the fact that we know it's there. It's in the system. We have to figure out and have enough management system to know how we're going to control that or make it available to us. So that's one of the biggest reasons why I've always run both tests in unison together, because one without the other does not give us that opportunity. So the bigger thing that we want to look at is attempting to make the system work better in that process. And go from there, we'll go down to the potassium, as you saw, was 227 on the Lamont-Morgan test, and we're running 182 on this system as parts per million. That's the difference is pounds per acre versus parts per million. So if you actually take this back to pounds per acre, there's a very difference there. Calciums, and these are all chemical. Some of the things that come into play, the big thing that I want to look at is when we look at this test, the Olsen and the base, then we'll go down to our base saturations, our Ks, our calcium, our mags. I want to see at least a 3, and they say between 2 and 5. I think a 3 is very, very critical. That's the lowest I want to try and see. And here we're at 2.22. Calcium, we're at 54, and we're at a 12. Well, if you divide those out, we're at barely at a 4-to-1 ratio. That still comes back to we're going to have a tough time getting that nitrogen to hold in that soil long enough. There's many other indicators that we can do. Let's take a look at CEC, the CEC of a soil. You basically have a calculated measurement there, and this is not a soil test course here today, but I want you to understand that when we run a system, this is a process, a soil test. We look at both those. Next system, the process, we want to look at nitrogen. As we look at nitrogen, it's a major component of every amino acid. Amino acid is the building block of protein. In fact, 78% of nitrogen can be fixed by your soil biology. And if you look at the blue in the sky, what I was taught by my mentor many, many years ago, the blue in the sky is the nitrogen. The next thing is we're going to cover nitrogens. You've been taught, or we've all been taught, we have urea, we have anhydrous, we have ammonium sulfate, ammonium nitrate, 28, 32, UANs, and these types of materials. I'm here to help you understand that in those forms, there are two. You have many forms, but you have ammonium and nitrate. Just to understand AH4, your ammonium is a seed producer used to set seed or keep blossoms. If we do not have ample of that material, we're going to have problems getting that crop, such as a soybean, edible beans, to put those flowers on and start that process. It's the trigger mechanism. Then you have nitrate. Your nitrate is what's considered for growth. So when we start on an early plant, let's say a seedling, and once it's beginning its germination process and growth, that's where your nitrates come in handy. And there's tons of soils that show me nitrate is available in the early spring, and there's lots of systems that say that. But our concern is that you have to have ample. You have to bathe that plant in these materials. So those are things that we're looking at always. So nitrate is used for growth. Use where you want to have lots of foliage, or use the bulk of crop up. I spent a short stint in the turf industry, and one of the things we found out is that they love to put urea, because urea has been, in the early 2000s, it was a very economical priced nitrogen source. And the biggest thing when we got to sports field, we couldn't figure out why they put it out there in May. They apply 200 pounds. You're getting 120 pounds of N on that grass turf, and all of a sudden they get seed head to bolt. Well, the biggest thing we have to teach them is that you're putting an ammonial form, an ammonial source that's going to force that plant to do that. You get back to a nitrate base or subnitrate ammonial, you can correct some of that. Some of the things we'll cover here now is your fruit and growth process continuum. Most people don't really know this. I've got some good friends that are plant physiologists, and, well, we never got taught that in college. Well, this may goes beyond some of that. What we want you to understand is there's a male and female version of this system. Your male would be your vegetative growing, your crop, your portion of the nutrients that are all male or vegetative. So we're looking at forages, grasses, leafy veggies, anything that's going to vegetatively grow. So when you look at those elements, you're looking at calcium, and you're looking at basically calcium carbonate, calcium hydroxide. You're looking at potassium, your nitrates, NO3, chlorine, probably your potassium chloride, testosterone, gibberellin, excuse me. The next phase, you get 50% past that, you get to female. You're getting fruiting, seed, set, and filling. And that basically comes down to your sulfur, your SO4, your phosphorus, acids, vinegars, ammonia, generally all your other elements that are there, estrogen, cytokinins, and ethylene. The biggest thing we have to remember when you're looking at this process, let's take a soybean. Even though a soybean may be vegetative, growing, but at the point when it hits a flower and wants to flower, we have to have female. We have to understand that either if it's not in the soil or it hasn't pushed that plant, we might force that plant to go a little more to the female side. Soybean is putting flowers in its form pods, and you have to go back to the male side to bulk that crop up. So these are processes that we have learned over the last 30 plus years. The next thing to cover is your controls of sugar in the sap, which does that. According to the Lamont test, we need 175 pounds per acre of phosphorus to have enough density in the top 6 inches of that soil to maximize production. A lot of times what we find out is that truly we are short on available phosphorus. I know that goes against some of the standard principles out here, but it is, as we find farmers, growers that are hitting the top yields, whether we work with them or don't work with them, this is one of the critical things that we're finding, is that available phosphorus is a very, very critical thing. It takes up to 175 pounds to bond with other positively charged cations, calcium, mag, iron, etc., to help move them into the roots and help hold calcium in that root zone. Potassium. We don't talk about it, and some people say, well, I don't see a lot of it in your program, but very, very critical at a point in time. There's a need for that when you're bulking. There's a need for that for fill size. So the critical things that we look at. But we always must be aware when we're looking at the potassium, phosphorus must stay in ratio with that according to our Lamont. When we look at that as a Lamont test. So with seed crops, P to K ratio, we'd like to see it as 1 to 1. On a leafy crops, we'd like to see that 2 to 1, just because there's more need for that. There's more caliber of plant and stock and material. So if we go to the next thing, which would be our calciums, my mentor taught me, and as well as they're unfortunately passing on as we keep through life. Dr. Reams a year ago this month, and Carrie Reams was well over 20 plus going on 30 years now, but very, very critical people that have taught part of this system to me. And the calcium was needed more by weight and volume than any other element. And what Reams always taught was that you must have a minimum of 2,000 pounds soluble calcium, not based off of parts per million and then these other things, and up to 4,000 pounds per acre, because it's basically a critical element as plant growth goes. Now, the sidebar note we have seen with working in sandy soils such as lower Michigan and parts of Nebraska, we have been able to see some change in that because of silica. And one of the things that we found, I think silica is changing that, and that brings up another dynamic. But I think silica has similar properties. We have found high silica levels in a soil will respond similar with fertility and high yields with the proper management as high calcium soils. Calcium application, best applied into fall, giving time to blend with the soil, break down. Generally best applied in ton amounts or less. We'll probably look at 1,000 pounds in a lot of farms. We have a product that Keith has worked for decades, Schwabco, in the process, a higher pH product, and ironically, it has never once raised pHs. For all the comments that we hear about this stuff, is that it's not raising our pHs. It's done a great job to keep it in check. In fact, if I look at Keith's soil tests over the last 8 years that I've looked at, he hasn't been much above 7. And he's putting on a very, very high pH product on these soils. So pH can vary, so I don't think I want to use the guideline. Applications during the growing season, so if you're going to apply some type of line, 10 to 150 pounds, it's best if you can apply with other fertilizers. So if we look at Scow was taught by Reams that if you're going to have the cooling and warming effect of ammonium sulfate, another sidebar note, you got to put calcium with that. That's one of the things people forget about. If you do not have high enough soluble calcium in your soil, it's going to be hard to achieve that cooling during the heat of the season or that warming effect from that ammonium sulfate. So by adding calcium to that, it's a very critical process. Dolominic lime, my best recommendation is never use. If you need mag, sulfur mag, there's other products that work very, very well. High magnesium will basically ties up nitrogen pound for pound. If you've got a high mag problem in relationship to calcium, it's no wonder we see 200 to 280 pounds of N being applied on some of these farms out here because simple basics are not followed. Other thing is it's slow to become available, and it causes the soil to become hard hands. Calcium function is cell wall strength and thickness, which helps fight against insect and disease. Adequate calcium produces structural rigidity, forms cross links within the pectin polysaccharide matrix. Calcium effects. Calcium has melting effects on the soil structure, improving drainage, takes less horsepower to work the same ground, feeds soil bacteria. Adequate calcium, less nitrogen in a producer crop. The biggest thing I want people to understand is that there's a lot of hype about gypsum. We get involved in it because Keith Schlapko has been very, very critical to talk about gypsum. And this is what I want you to understand. In most cases, except for the polyline that Keith has been applying, I have yet to find a gypsum, a mined or a synthetic gypsum, that will increase soil calcium at the surface. Now, that doesn't mean it's not going to be higher as we dig down in the profile, but if we're trying to affect the top 6 inches of that soil, that is very, very critical. We got a grower, he's a great no-tiller out of north of Flint, Michigan, Robert and Ann Adamick up there. They're great people. They have a unique approach every fall. They use 1,000 pounds of gypsum and 1,000 pounds of ag lime, and they have been raising beans on beans. And this is similar principles they were taught using the same thing, understanding if you're going to have gypsum, you must have calcium with that. And they've done a great job of following those rules. Humus holds water, buffering capacity, improves microbial growth, improves soil tilth, improves aeration, easy for plants to develop root systems, diminishes the unfavorable effects of excess amounts of fertilizer and sprayed minerals. Soil is a colloidal material. A colloidal compound is a material that has microscopic substances dispersed throughout another substance. Milk would be a good explanation of that. Nutrients available can be increased by spraying 10 gallons of 2% sulfuric acid per acre because it lowers the pH, frees certain nutrients. 2 gallons of sulfuric acid in 100 gallons of water makes basically a 2% solution. This will help balance your soils and reestablish a dynamic equilibrium. This is one of the things that Reed's constantly talked about, these little things that made a difference. What you're seeing here is basically it's the biology. It's the next macronutrient, in my opinion, and we've worked with this for years in our process. Good or bad, I believe strongly that we are looking at a new dynamic. If you look at this picture on the left, it is corn roots. That's obvious using micropack. This was in Osage, Iowa, down at our soil sales manager's farm, Bruce Johnson, who's actually a farmer down there. He's our sales manager for the company now, and showing some of the roots that came off his farm first year into the system using a microbial product along with his starter. Because anytime you add a microbial product, you must have a food source with that. It's just how it standardly works. On the right-hand side, a grower from South Dakota, but our micro sprout on the wheat plant, showing a biological, showing our system. And there may be a few more plants there. This is something he did on his own. It's not something we did. He sent us the photos. He's very, very impressed with that rhizosphere. And these are critical things. One of the things to be aware of as we progress forward in our dynamics of this, we have been looking at products for years and using products. We have finally got to the ability to produce our own bugs in-house. That's been probably the newest dynamic of FHR, is that we have our own processing system due to the work that is done through our lab here, CSI. So soil biology is the key. All nutrients must be transformed by the soil microbes. into usable forms for the plant to uptake. So the thing I always love is we're always hearing snake oils. And, well, if this is snake oil, then it's the original snake oil because it's been used for decades out here, for millennia. As we have soil microbes we process. Now, I always hear that these microbes are here, they're just not available. Well, we know that through modern chemistry, and I'm not here to talk about the detriments of glyphosate. That's not my issue. Anytime you put a material, pesticide, fungicide, they all have detrimental impact on our soils in some way, shape, form, or another. And if we do not have livestock, which we have less and less of that now than we used to, these are basically going to be problems. So we felt that by putting this back into the system, we can change that. The soil microbes eat at the first table. The plants eat at the second table. It's that basic. So this establishes a dynamic equilibrium. Abundance of soil microorganisms. When you look at the process, because I hear tons, earthworms. I've been to the no-till conference 5 or 6 years now, and I've been very proud that I've changed our operation to this no-till. Not everything, but we're a very, very large portion of our farms that we actually either run ourselves or we manage for people. We custom farm. We're getting the custom farms even to move over towards no-till, so it's a good thing. But if you look at earthworms, 1,000 to 1,500. Mites, 5 to this is this pounds per acre and 6 inches. So 1 to 1,500 of the earthworms, mites 1 to 550. Nematodes, we're looking at 10 to 150. Protozoa, 20 to 200. Algae, 10 to 500. Fungi, 1,000 to 15,000. Actinomyces, 400 to 5,000. Bacteria, 4 to 500. When you really look at the dynamics, you look at this whole thing and this process, there are more activity by the smallest of the population. In size, when you look under a microscope versus the earthworm. And there's so many people are worried about earthworms. And don't get me wrong, I think they're critical, but I think there's more activity going on by them bugs than anyone realizes. The rhizosphere, simply put, we have a simple system here. The zone of the soil is that significant influences the living root. Usually it soothes about 2 millimeters out from the root surface. The rhizosphere is enriched in organic material due to the root exudates and sloughing off of those root cells. Microactivity in the rhizosphere may be 2 to 10 greater than in the bulk soil. So when we look at that whole process in that root zone, those are critical nutrients around that root. And my goal eventually as a no-tiller and as a farmer, I want to be able to take that root ball, chop that up, and plant right back into that zone because that is where your most activity is. We've talked about rototillers, this, that, and the other thing, and who knows what insane thing will come out of our process here, but eventually I think that's going to be a great way as long as we get that seed-to-soil contact because it's going to be critical. If we get too close to that root ball, we know we have problems with that. We're showing here the nitrogen, the atmospheric nitrogen, the whole process as we're looking at this. So this would be your nitrogen cycle. If you notice under the ground, all the cycles is mediated by soil microorganisms. Notice there are nitrogen-fixing bacteria on the roots, as you can see that up in your left-hand corner. And then you get to the soybean. Below that, you begin the nitrogen-fixing cycle, showing the process that we go through. Free-living soil bacteria that convert nitrogen in the air to ammonia, NH4. This is called ammonification. Another group of free-living microbes take the ammonia and convert to nitrate, NO2, which is a poison. Then the other set of microbes convert NO2 to a plant like nitrate or NO3. That is, there's a way nature provides nitrogen for growth and protein building blocks. So what it comes down to, this is also what has FHR borrowed from nature and incorporates into our micropack and our other biological products. What we're showing you here now is basically a testing system that has been run here. It's a beta test. We've talked about it for many, many years now. Dr. Michael McNeil had a soil testing kit that he had caught many people prior to that, so they just came out with a quick testing system that works very, very well. So basically what we're showing here is that where we had micropack at 24 ounces in the soil, we got 26 pounds of N release. Micropack at 48 ounces with fertilizer, you get 46 pounds of release. And if you go to the micropack at 64 ounces of fertilizer, you get 80 pounds. B-Hume at 4 quarts with fertilizer, you get 80 pounds per acre of N. B-Hume at 2 quarts of fertilizer, you get 90. So it can be all over the board. The thing I want you to understand is you even take 80 pounds of N at today's price, that's around $40 an acre. When you're looking at a cost of micropack or a B-Hume, anywhere from, let's say, 10 to 15 bucks an acre, you're still coming back with about $15 net to $20 an acre net back to the farm. We don't talk about this stuff because it's a way to fleece a system. It's a way to make enhancing a system and making it more available. Soil biology. Basically, mycorrhizae is one of the things we talk about. We're very proud to handle these products for the company, West Coast-based company out of Oregon. The mycorrhizae fungi increases root area, absorption P, absorbs microscopic water, builds soil structure, attracts other microbes and biology. And it is one of the things that we are adding into our micropack. Synthetic production tips: inoculate soybeans seed with rhizobium and mycorrhizae fungi. Why? Recent research has discovered that there are several genes in the soybean genome that encourage symbiotic infection of mycorrhizae fungi. So when you look at wanting to figure out how to get more nodulation on your soybeans, these are things to be looking at. One of the things we found with one of our good farmers down in Osage, Iowa, Mike Lewis, has been with me 22 to 3 years. We had a tough time getting yields up when we started looking at it. We just had a high nitrate, which made a lazy crop. So we had to figure out ways to counteract that. So these are some of the things that we're doing in these systems. Without mycorrhizae fungi present, these genes are not switched on. So it's like no different in your body. If you have an alignment on your spine, out of alignment, you go back and get that adjusted by chiropractor. It's like turning on a switch in your power box breaker. So, however, when switched on, both nitrogen fixing and the increased phosphorus biologic pathway are increased. So, food. If we look at plant root fixates from the root is food for the microbes. Each plant has a unique buffet: organic material, manure, compost, material humates, crop residues, powdered fertilizer like power lime, soft rock phosphate, soluble calcium fertilizers blend in with microbes always. Limiting your tillage. Mycorrhizae does not like to be disturbed. Always have something growing to avoiding fallow periods. Benefits soil microbes live in and around the root zone. Life beget life. Consider companion crops as cover crops. Avoid drastic changes in soil pH. So, introducing new friends, including fresh bacteria, have a micropack, or B-Hume, mycorrhizae products to mycorrhizae applications incorporated, foliar stimulant, seed inoculants, microsprout, and mycorrhizae applications. We're going to go to the non-GMO seed portion of this talk and talking about the co-op that I got started with Keith and Rusty Packer and Jim Nelson, and then the CSI labs that is backing up some of the things we're doing with the genotypes of that grain, as well as testing for glyphosate. Those are critical things. So as we look at where we're going as a nation and in agriculture, we have a couple things going on. We have the cereal companies that have gone public, basically Cheerios, grape nuts. Those are two products that are coming out of this world. I think there's going to be many to follow, good or bad, whether we like Chipotle's. They're trying to go down this process. Basically, we look at it as growers. We have options. We have the ability to make choices, and I think as we make these choices, these are things that I think we want to look at and try to figure out how to tie into this, because there will be, and it's going to be, non-GMO premiums for these, and it's going to keep getting better and better. One of the things through FHR and partner with Genesis and CSI, There'll be better premiums from non-GMO seed, and it'll be guaranteed to be glyphosate-free. We've already gotten farms this year that have tested zero glyphosate on non-GMO crops, so that is a big plus. Genesis grain, just showing some of the things that we saw in 2013 on our test plot here, just showing some, basically what it comes down to is Genesis, give me a second here, get caught up. Basically, 2013, they were corn foliar trials, just showing some of the things that we've looked at, program that we ran on these. We were running 7 gallons of H16.3 of water, micropack, 250 pounds of 1797, and 25 gallons of 32% with our Calzol product. We side dressed with 20 gallons of 32%, 1034 B-Hume, 12 ounces of molasses, along with our Personova water, structured water, using RO water. Foliar sprays, 24 ounces of foliar stimulate with a quarter defender, 3 quarts of foliar N, and then our Personova water, basically showing different genetics that we're seeing, 2 Genesis numbers at almost 186 and 143. And then we got to another company, 120 and a 121, just showing that there was a big difference in considering these plots were planted the 15th of June because of our weather. Protect against stress, fertilizer with millions of microbes, micropack, and B-Hume. Precision farming, not so much high-tech as it is common sense. The application is the muscle of a successful system, the right material, biology, seed, fertilizer, chemicals, at the right time, day of month, crop physiology with the right equipment, wheels or wings, soil or foliar, reduced environmental stresses, saves time and labor. So we look at, this is one of our planters. This is a 12-row. As you see up there, it's set up as the Utah planter. It has been converted to be a seed corn planter for the seed division for Genesis this year. So we have taken some of the things off that and got it mean and lean. This is basically the video that we have done. It's showing you the Utah system, showing ammonium nitrate, ammonium sulfate with humates, and our dry material that goes down through the coulter on your right. And this starts a process. You've got NPKs, and then on the left-hand side, we'll take 32% with our Calzol, or as a new product we are carrying now that we've developed called Nutramax, and running that in conjunction with that to have the amino acid effects. And you get that synergism, that electrical charge to create that growing environment between that cation and anion, negative and positive charges. So as we look at this. And then we take our 819.3 or 100% ortho product with our micropack or biology again, and you drop the seed into that zone, giving it that effect. As Keith built the first planter that we got, is that U-trough, giving that total impact around that seed. Precision tools, so some of the things we do is we run the 240 pounds of soft rock in the fall, 20 of MAP, 20 SOP, 20 of KCl, potassium chloride. Then we'll run a liquid of 415.8 with some sulfur and some humates. We are running a coulter system. There are tons of dynamics and then deep physiological conversations on that. I'm not here to get into that. We went with a coulter system because what I've seen from other companies. This is actually our strip till rig, and that was done in late May. You can see the color of the soil, and if you look closely at some of the things, and whether or not it's showing you, this is a video, I hope it is, but what we're seeing, we were very, very wet. We had 16 inches of snow the 2nd of May, and it just did not get really any better. You can see the mud coming off the system, but we were so fortunate we could strip till, put our materials into that zone, and we could actually come back in and plant within an hour or two. If you notice on the saddle tanks on the tractor, we're using our humate-based materials within that nitrogen to help stabilize that product. And with the amount of moisture we had, it was a tough one this last year. But you can see the coulters. It was a wet year. But ironically, what I learned from this year is that even with wet conditions, you can have a good growing environment. The farm where we're on right here, it had 247 bushel corn raised. It was planted the 29th of May. And we had anywhere from about 179 on that 300-some acres we planted within 2 days to 250, 260 bushel corn. We know we had well over 200 bushel average considering how the year was. You can see on the back end of the strip till rig, the non-tag card, it was absolutely just, it was not good conditions. I went against everything I've ever talked and promoted, but unique times create unique people and unique circumstances. The application of foliar nutrition is one of the critical things that we look at, whether it's a plane or a helicopter. We've got great people that we've got working with us. Rick Ketley out of Illinois, down by Rockford, and then we've got the Kreider family, who is out of the Joliet area. Rick runs plane, the Kreiders run helicopter. I'm both a big advocate of either system. I think they both have their place. Sometimes you can get a little more finite because we're in, as they call it, hillbilly country. Lots of hills. We can make this system work with a plane, but it sometimes works better with a helicopter. So I'm not worried. Foliar application of nutrients, foliar applied nutrients, basically it's pretty simple when we look at the whole process. Is attempting to look at what we can do to amend a crop and amend it properly. So when we look at foliar treatments, they're absorbed within minutes. You know, and there's so much snake oil. Well, Michigan State did tons and tons of research on this in '53, I believe it was, showing it seconds, this material, because through the system that they use to track it, radioisotopes, that they put that into the material, see how quick it tracks through the plant. It's no different than doing a CAT scan or an MRI on a human body. They put a dye in there so they can see it. Similar process to this. So the system has proved itself over the last 50 plus years. I think we need to realize that with so much going on with a crop, more than what we realize, foliar applied nutrients are very, very critical. So basically, when it's too wet to be applied, for ground rigs, you know, you're in the hills like we are, there's tons and tons of reasons why to look at alternatives through foliar nutrition. I know one thing, as I've watched Keith and other growers such as Mike Lewis, they're at this 90 to 100 pounds an end, and they are getting by with raising the crop off that process. So it is very critical. Remember, when we're in female, we'll go back to this SO4, phosphorus, your vinegar, your ammonium, all the other elements, estrogen, cytokines, ethylene. Those are all critical things to look at. Some of the things that we have in our proprietary product line is our Defender product, which is copper, boron, iron, zinc, manganese, magnesium, copper, molybdenum, sulfur, and then there's nickel as well. And these are critical things to be able to put into that program when you're trying to raise that crop. Plant growth regulators, a PGR, such as foliar stimulate. You look at specific nutrient formulas, the Rondos, which is a bulker, foliar N, which is a supplemental N source that gives that quick burst to be able to change that plant. If you're in more of a male cycle, you want to switch it over to quick female. That's one thing to look at. Seed set, product that was designed primarily to set seed, trademarked that way. Very, very unique product we designed. It has over 16 different elements in it. Copperite, as we talked with Don Huber, we tried to figure out a way to bring copper in, and that's one thing I want to hit upon. If you are attempting to change nutrition, you can blend these materials together. If you're trying to have a fungal type of treatment, then you must look at some of these alone, especially copperite. If you're going to control some of the natural disease issues we deal with, sometimes you need to look at these alone and not blending products with them because they work better, and copper is one of those. You want it as a fungal product, a fungal treatment, then you need to look at copper alone. So when to apply, so when we look at micronutrients and PGRs on corn, V1 to V5, beans, V2 to V5, side dress, used as a nitrogen stabilizer, V3, V4 on corn, V1, V2, V5 on soybeans. Ammonial N, seed setter, trace elements, fungicides, V10, V8 to V10, pre-tassel, pre-flower, ammonial N on trace elements, and fungicides V5 to R1, ammonial N and trace elements on corn, R1 to R2 late season, late season bunker on corn, R3 to R4, and R5 to R7 on soybeans. Some foliar trials that we've done in 2012 in the Norris Springs area, looking at 136 with using Rondo as a bulker versus 120 on the check, no foliar. It was a 16 bushel increase. Um, Even at today's prices, you're looking at over $50 cost and something like that. These are big things to look at. So you're going to make an ROI on these type of things, which is massive return on investment. Trace elements, content of soybean leaf tissue sprayed with Biomax Defender G4. When we actually looked at applying this to the plant tissue, we saw 253% increase on iron, 540% increase on manganese. Boron was 120% increase. Copper, 351% over the check, and 1,173% over zinc over the check. So foliar nutrition, in my opinion, is no different than using IV therapy. You know, it's going to directly inject it into that plant versus taking a pill or trying to put it dry out there. And I'm not against dry, folks. I'm a very, very firm believer in dry. But I think we have to truly look at this whole thing and then be aware of what makes us the biggest impact. Trace elements, content of soybeans, pods, 2 weeks after foliar application. So when we look at after the application, so we had a control on the left and the Defender product on the right, 13% on iron, 22% on manganese, boron was 12%, 6% on copper, and 71% on zinc. So the biggest thing here is your road to success is going to basically your biology. The most important livestock on your farm. This, in my opinion, when you look down the road 10 or 15 years, we're going to find this to be very, very critical to long-term success of agriculture. Testing, soil, tissue, water. If you can't measure it, you cannot understand what you're looking at. But always remember, it is a vision of one point in time. Application, ground, air, it's all about timing, folks. Fertilizer, chemical, biological, foliar, these are all critical things. And then we're not here to tell you that it's one thing. It's a unison. It's a systems approach. And these are very, very critical to where we're going long-term with our process. I guess I'd like to say that it's one thing that we do, whether it's myself or Keith Slapko as a partner, and then other people within Genesis, such as Rusty Packer, one of the things we pride ourselves on, we are farmers first. Whether or not that makes good sense to some people, but we are wanting to grow the best crops possible and showing the nutrients first and the density of these nutrients when we build these programs, and then they come out to you as a farmer. So may your crops be nutrient dense and bountiful. So my biggest thing is that have a safe spring and make sure that we have the opportunity to build a good process. Daryl, I don't know if there's questions right now that we can bring
Sure.
up.
No, thank you very much. Thank you very much, Jeff. We do have some time here to take some questions. I do want to encourage you, if you've got any questions you'd like to, or some things you want to follow up or have Jeff follow up on from his conversation today, go ahead and enter those into that the question or comment field that appears on your screen. And again, that's by clicking on that orange box with that white arrow, and it opens up that larger field. Let me just start with this one, and we'll get to some of the questions that were asked. And this is one that I was just thinking of as you were talking. But you've worked with a lot of growers on fertility programs, and when folks come to you and want you to take a look at their fertility situation, are there some what I'd call most common issues or problems that you often see that need to be addressed when we talk about just starting from the beginning and starting with basics?
Yeah, Daryl, the biggest thing I see always is the calcium. It's probably one of the most overlooked nutrients that we deal with out here. That probably be the starting point. We have to have enough soluble calcium in the system. We have to have enough phosphorus. And those are probably the two most overlooked, because the whole world is taught that to raise a crop, all you need is nitrogen and potassium and maybe a little phosphorus, and I don't believe that. As we get out here and we travel, you know, in 14 to 15 states, and we communicate with our neighbors to the north in Canada as well as Australia and New Zealand, and we've got opportunity with some folks in UK, and we're finding out that these are all universal problems across the scope of this thing. Is calcium is probably one of the weakest links, and then your phosphorus. I think you have to have those in tune. The biggest issue of all, which I first got taught, and I grew up in central Minnesota, North Albert Lea. You got wet hoofs. You can't fix that problem with all the amendments in the world. So if you're dealing with wet soils, I think the critical thing is, first step, I guess, out of all we look at is probably draining those soils. If you can possibly do that. Drain the soils and then come in with your amendments from that point in time, or figure out ways to channel that moisture away, because we have to have a crop that can maintain in a good zone without losing nutrients. And if we are in muck soils that hold water too long and we can't wick it away, dynamically that can be a major problem as we look at it.
Okay. Let me go to some questions here that have been submitted. One that just came in talks about our soils in western Nebraska are high calcium. It looks like 4,040 parts per million, if that's the right number, and high potassium at 470 parts per million at those levels. Do you have any opinions on anything they can do to help release those nutrients? Again, high in calcium and high in potassium.
One of the things we work, we got a fair amount of western Nebraska and central Nebraska, and a lot in eastern Nebraska. But one of the things we found is that inherently the folks in Nebraska are blessed with high potassium. One of the things that we have found is getting folks to look at using a soft rock with a humate in it. One of the companies that we've looked at is Live Earth out of Utah. Dave Taylor out there. Great process. They take Idaho phosphate, and they take that and mix it with the humates coming out of Utah, out of the Bureau of Land Management out there, and it's been a great process. One grower in particular, Dwight Johnson, we've got out of Elm Creek, he's had great opportunity to change that. He's actually gotten those high potassium levels to level off, gotten a 1-to-1 ratio. On the 4,000 parts per million of calcium, it's got to be based off of a CEC test. I've seen 4,000 parts per million on a CEC test, but on the Lamont test, it could be much, much lower than that. So I'd be guessing at best to tell you that I believe that we see that as the high calcium. But if it truly it is, there's a lot of things you can do, but having magnesium in ratio with that is going to be critical. But that would probably be the biggest thing is getting back, even though you're getting calcium out of soft rock, it's still not going to affect that soluble calcium, even though you have high calcium in those soils. I'll never believe that we can't put some calcium into a system and not have an impact from it. Calcium begets calcium, so if you're wanting to release some of that, calcium is a great way of doing that. Ammonia is another great way of doing that. You look at the Albrecht papers that are out there from Missouri. Albrecht taught 1-to-1. You'll lose, for every 1 pound of ammonia applied, you lose a pound of calcium. You look at the periodic chart, potassium and calcium are 1 atomic mass apart. You're going to get some interaction there. So those are things that I guess, I'm not sure if I'm answering it quite right, Daryl, but that's a critical thing to look at. But is it truly a good measurement? Not anything against any lab, but I think is it a truly good measurement? And once you look at that as a soluble test versus a CEC test, you can have a clear idea on that, I think, Daryl.
Okay. Here's another question. It's regards to your soybean inoculant product with rhizobia and mycorrhizae. What is that product again? What's the cost per acre on that?
What we're doing is we've got microsprout, which is the liquid. On the mycorrhizae, I'm not for sure. You can call in and talk to Ava. I believe it's a little bit higher if you just run with straight mycorrhizae. Running with the microsprout, which is applied onto the seed, I'm more familiar with that because I developed it. That's going to be in that $2 to $3 per acre range, I believe. It's not a very, very high cost. It's in the cost with some of your other inoculants. It's not a dry; it is a liquid. We have not gotten down to that level yet. I've moved into the dry arena. There are many, many good companies out there, such as ABM out of Van Wert, Ohio. They do a phenomenal job working with those type of materials. But at any rate, we've got the rhizobium plus a slew of other microbes within that process. But I'd ask you if you're for sure on the mycorrhizae, I'd call into the office here and talk to you on that one. I don't mean to, I'm just not up to speed on that one with all that's been going on right now in my life.
Jeff, is that your same mycorrhizae product for corn, or do you have something again different on corn?
Uh, I have, I'm kind of funny this way, Daryl. The whole world thinks, the microbiology thinks that there's a finite rifle approach to doing microbes, and they're really what we see as a farmer and a layman. I see it as a shotgun approach. I'm going to blast everything out there. Whether or not you need rhizobium on corn, yeah, there's going to be people like, he's absolutely wrong, and they could be right. But I know as we put in rhizobia into a corn program, we stimulate microbes. That is my whole objective. Is I want to stimulate microbial activity in the soil. I don't care what we're doing because, ironically, the microbe population in the soil is somewhat inertly intelligent enough. They don't overpropagate or propagate that profile. If one species becomes too overwhelming, another one will come in and somewhat control that. They're believe it or not, there's been a kind of a unique system there that we've much overlooked in the last decade in agriculture that is very, very critical to where we're going to be in the future. So my approach is this, Daryl, simply, I'm going to probably use similar microbes. There might be one or more that is higher within these processes, but it still comes down to that I think they're all needed, and they're all needed in a shotgun approach because certain ones, anaerobic versus aerobic, it's all based off of what that soil profile is going to do. If we get too hot, we get too cool, we get too wet, we get too dry.
Okay. Hey, Jeff, do you have any particular base foliar recommendation for soybeans?
Uh, yeah, we always, we'll try to start out with a good nutrition program underneath the plant. Um, Make sure your calcium and your sulfurs are up there because protein production is critical on soybeans. You get that accomplished, and we try to come with micronutrients very, very early with ammonia, setting that plant up. Mid-June, prior to flowering, that's the summer solstice, we'll probably come in with a dry ammonium sulfate with some bell lime, 50 pounds of AMS, 50 pounds of Pell lime blended up, blow that over the top of that field if you can do that, then come in with your foliars. And with that foliar, it'd be like our seed set at like a quart per acre. Quart per acre of ammonia, 16 ounces of our Defender product at that point in the game. And then we'll use a little bit of potassium chloride at about a quarter to a half a pound per acre, C90 at a quarter to half a pound an acre. And then based off what we're seeing, if we need fungicides, insecticides, we may add those in. We'll probably give that about 2 to 3 applications. Then we get to where we have pod formation. We'll back down on the seed set to like a quart, like a pint per acre, maybe a pint of the foliar N, and then we'll start coming with our rondos. And back up for a second. We're probably going to always try to get a little bit of calcium nitrate in that early application just to make sure that we're seeing cell formation. That's one thing Keith has taught me. It's a little harder to put that in with some of these products, but if you have ample and good water, you can do that. So running that, and then we'll back to where we were on where we have pod formation. We'll put the rondo in, potassium nitrate, calcium nitrate, back to your chlorides, being a little bit, another pound or so of potassium chloride in your C90s, little Defender, and then it's going to vary from there. But I mean, we'll probably hit it with 3 shots there. You might hit 6. Depends on your budget. I mean, one thing that Scott taught me over the years, put down the right elements or the amount of elements you need. Just you can't afford it, then just put less of those elements. But never short the crop and give it as much as you can, even within a budget, if that makes any sense at all, Daryl.
All right. No, thank you, Jeff. Thank you again for taking the time today, presenting the webinar, and for answering those questions. And we're going to wrap things up here, but just before we conclude, just a heads up that you're going to get everybody online here today will get an email shortly. There'll be a couple things in there. One, there's going to be a link to a survey that we'd really like you to take. It helps us evaluate today's webinar, and it gives us some info we can use to improve upon future webinars. And also within there, we will send you the replay. You'll get a link to the replay of today's webinar and the event you'd like to go back and review the entire presentation or parts of it. You'll also find that replay is going to be posted up on our No-Till Farmer website shortly. There's an archive section on the website where you can go back and listen to other recently completed webinars as well. And so I really, again, thank you, Jeff, for joining us today. And I want to thank the folks at FHR for leading this webinar on fertility. I also want to recognize and thank our producer today, Cole Vandermouse, for handling the technological aspects of this webinar. And we sure hope that you'll join us again for another No-Till Farmer webinar soon. Thanks for joining us. Have a great day.